Some of you are going to be gone Wednesday. Today is hopefully not too new of stuff, but if you're gone tomorrow, right? I see you tomorrow, Wednesday. Then watch the video. Hopefully that will help. Yeah. What's an equation versus an expression?
Equation has an equal sign.
Yeah, an equal sign. You solve equations. You simplify expressions. You solve equations, you simplify expressions. So, for example, I give you 2x minus 4 plus 7 x plus 1. Go for it. In this bad deck, there's no directions. There doesn't need to be directions. What'd you get? 9x what?
9x minus 4y minus 5.
Why isn't it 9x equals 4y plus 5? No, it's equal sign. So we're simply distributing and combining like terms. Nine x, is that correct? Is that what you said?
Yes.
Minus 4y minus 5, is that what you said?
Yeah.
That's it. This is a simplified expression. This is a simplified expression. You don't have to just throw in an equal sign.
If only it was that
What's that?
If only it were that easier to test.
Oh, well, you know, can be depending on how much you know the material. It can be that easy. So now I'm going to give you x squared minus 6x minus 7 equals 0. Is that your stuff, or do they meet good Spencer's?
I think it meets up the
Great. Just wanted to make sure. First step? Yes, factor, factor, factor. And this factors as. Oh, shit, what's the x doing? Double x. X minus 7. That what? What? Okay. Are you done? No. What's x equal?
7.
Okay. What is the degree of this equation? 2. The degree is 2. We started with the quadratic. How many answers?
2.
Okay. Great. What if they don't always match? What if the degree doesn't match the number of solutions?
One solution happens twice.
One solution might happen twice, but if it happens twice, that is still considered 2 solutions. Angelina. This is 100% voodoo math. Like, this isn't even close. Yes, Miss Angelina, I hear you, like, talking to Gail. What's going on?
You can't make one of them 0 because that means that the other side has to equal 0. You can't, because if you multiply it with 0, then
Oh, I erased one of the answers. What is one of the answers I got? 2? One of the answers was 2. What's 2 plus 3? 5. What's 2 minus 1? What's 5 times 1? Oh. What's the other answer I got? 6. 6 plus 3 is 9. 6 minus 1 is 5. 9 times 5 is 5. It's not called the 5 product property. It's called the 0 product property. So how does that work? Maybe you've seen it, maybe you haven't. This is supposed to be a time sign. Okay, so you have 2 quantities, A and B. You have 2 quantities, A and B. If A is 0, what's B? Is B 3? Sure. If A is 0, 0 times 3 is 0. What if B is 27,000? Still 0. What if B is infinity? Still 0. So if A equals 0, then it doesn't matter. Even if it's imaginary, 0 times anything is 0. Doesn't matter. If A is 0, who cares about B? It can be anything we want. If B is 0, what about A? Same thing. It can be anything. Okay, but that, what?
Let's both be on 0.
0 times 0 is 0.
Oh, okay.
Yeah? It's 0 divided by 0 that we have issue with, but 0 times 0, who cares? What am I going to do here? Kyle?
Yeah, that's time to 0.
Okay, make the right-hand side to 0. So, Kyle, continue for me.
You could subtract 5.
Okay, subtract 5. Does that equal 0? If I subtract 5 from both sides, do I get 0?
Yeah.
Yes, but, come on you guys, what's wrong? You gotta multiply it out. Yeah, you have to multiply it out. Then you gotta factor it.
Oh.
So let's multiply it out.
Oh, that's smart.
Oh, Nate, stop. Combine like terms. And now factor it. Combine like terms. And now factor it. Oh, good. Tell me it's factorable.
Yeah.
It is? Okay. It is?
Yeah.
Right. 42.
Actually is.
Factor. Now you can use the 0 product property. There's no such thing as the 5 product property, or the 16 product property, or the anything else product property. 0. How's it factor? What's X? Okay, check just to make sure. Plug into the original equation. Make sure X is -4. What's -4 plus 3? -1. What's -4 minus 1? 5. What's -1 times -5? 5. Perfect. 2. What's 2 plus 3? What's 2 minus 1? What's 5 times 1? Boom, it works. Excellent. Well, the 2, that was pure luck. That was pure luck that the 2 worked.
They were very lucky.
Okay. All right, none of these are rational. None of these are rational. What's it mean to be rational? Fraction. So none of these are rational. You've been graphing rational. The asymptotes, the obliques, the end behavior, the bounce, the cross, whatever, those are all rational. So let's solve. Why do you say x minus 1, Nate?
Because fraction. So
So Nate says multiply both sides by x minus 1, which I agree with. Let's work on the explanation. You do multiply both sides by x minus 1.
you don't want x in the denominator.
I don't want x in the denominator. It's difficult to solve. What do you, if I gave you x plus 2x over x minus 1, and I asked you to simplify that, so you were doing this a couple days ago or end of last week, whatever, how do you simplify these? Okay, so Victoria says multiply this.
No, just the fraction.
This one? You want me to multiply this by x minus 1 over x minus 1? What's the common denominator? X minus 1. The common denominator is x minus 1. So you're going to multiply. You're just doing this. Do they have a common denominator now? Yes. So this becomes x minus 1 over x minus 1 plus 2x. Yes?
What, can't you just multiply by x minus 1 over 1? So that, like,
That's changing the value of the fraction. Just randomly multiplying by x minus 1. You have to multiply by x minus 1 over x minus 1. That's just a fancy form of 1. Is this done?
no,
What would you do?
combine both.
Distribute? Combine like terms? Yes? Okay, so what's the common denominator here? X1 minus 1. So you're multiplying through by the common denominator. So when I asked why x minus 1, it's because that's the common denominator. Whoa. Here Nate said, can't you just multiply by x minus 1? And I said, no. But here you can. What's the difference between the one on the left and the one on the right? Yes, this has an this is an equation. It has an equal sign. I'm balancing one side's x minus 1, the other side's x minus 1. There we go. First fraction on the left. What do I get? Oh, you did it ahead of me. 1 second. Yeah, you're a step ahead, sorry. You're distributing x minus 1 times x. So it's x minus 1 times 2x over x minus 1. 2x, fantastic. And on the right, fantastic. You were just doing this. Distribute, combine like terms, factor, etc.
So I did find that.
Compare with your neighbor, see what you get. You should always compare with your neighbor, see what you get. Distribute, combine like terms.
Plus x is 2x minus 3.
What do you do once you get here? Subtract 3, add x. Why are you doing that?
To get it equal to 0.
To get it equal to 0. Oh, help me out. That's 3x? 2x.
2x.
Thank you. Factor it. Thank you. X plus 3, x minus 1. What does x equal? Nope. Amelia?
Is it because the original equation doesn't have the second degree?
Okay, so the original equation has a degree of 1. How many answers did we get? Sometimes both answers will work, sometimes they won't. -3. Plug in -3. What do you get? Plug in -3. It's -4. Doesn't work. When you plug in -3,
It can't be 1 because then you get 0 in the
it
denominator.
cannot be 1. You need to check your work. From the very beginning, x equals 1 is an undefined solution. What's it mean to be undefined?
Zero.
0 in the denominator. What's that look like on a graph? What does 0 in the denominator look like? Or an asymptote. Fantastic. Yeah, Michelle.
Instead of multiplying the whole thing by x minus 1, could your answer have an expression in the denominator? So like it would be like x plus 3 times x minus 1 over x minus 1 equals 0. Then you
Okay,
know,
wait. Perhaps. Go backwards. Start over again, please.
like instead of multiplying by x minus 1 first,
Okay.
what I did was I just subtracted 2x over x minus 1 to.
Oh, I see what you did. Okay. Yeah. Yes. So what Michelle is saying is she subtracted 2x over x minus 1 because then she has a fraction with common denominator. So she did 3 minus x over x minus 1. And then she subtracted 2x over x minus 1. They have a common denominator? Okay, so you get x equals negative x minus 2x is negative 3x. Yeah, Michelle, is that right?
Yeah.
Combining like terms in the numerator. Now what?
And then I was subtracting x, but it's like more work though, because like I was subtracting x and then subtracting.
Oh, you don't have to. You don't have to subtract the
Just
x.
factor
Just
them.
factor.
Just factor. Yeah. So it's like you started it, but then you made it more complex. But if you factor out a -3, if you factor out a -3, you reduce out the x minus 1, and you get x equals -3. Okay, so what happens when there's not a common denominator, though? Then it's not. So this is great. No, this is fantastic. This is a great way to. This is a great way to do the problem if you recognize that there's a common denominator. Yes, Victoria.
But how would you do it if it's not a common denominator?
So let's do one of those. What happens if it's not a common denominator? Let's look. I'm not going to say you can't. It's just a lot more complex in my brain, but that doesn't mean that it's, more complex. All right, what happens when there's no common denominator involved? Sorry, -4. How great would that be? That's not what you're supposed to write. This would be awesome, yes? I know. What about it's x plus 2? I changed it. I was doing that just to fool you. I know, so nice. So I would, common denominator? No, like I can't just add 3x plus 2x, etc. What could I do?
Factor out of 2.
Not gonna help me.
Multiply by you can find it.
Yeah, let's multiply 3 by the common denominator. So Kaveen said,
If it was a plus.
yeah, but it's not.
Why can't it?
Because it can't be. Kaveen wants me to magically make this an x minus 2, whatever it was. So if you factor out a 2, oh, how great would they be? Would that be if I could reduce? But can I reduce these? No. So stuck. Okay, so Saran, what did you say?
Multiply 3 by the least common
Yeah, multiply 3 by the least common multiple or the lowest common denominator. Which is what?
X minus 1 times x plus 2.
Yep. X minus 1 times x plus 2. Oh, that's a 2. When you are done multiplying through, there should be no more fraction. That's the whole point of using the LCD. So the first fraction, when I multiply quantity x minus 1 x plus 2 times 3x plus 2 over x minus 1, what reduces? X minus 1 x plus 2 times 3x plus 2 over x minus 1. What's going on? Yeah, the x minus 1 is reduced. That's the whole point. You're getting rid of the fraction. The whole reason why you chose x minus 1 x plus 2 is so that you could reduce out the denominator somehow. So this becomes quantity 3x plus 2 times the quantity x plus 2. 2x minus 4 is going to get multiplied by what? X minus 1. If you were to distribute x minus 1, x plus 2 times 2x minus 4 over x plus 2, the x plus 2's reduce out, leaving you with x minus 1. What happened to the fraction on the left? What happened to the fraction on the left? Where is it? I had this fraction, Where's the fraction? It's gone. That's the whole point. That's the whole reason why you multiply 3 by the common denominator. It's gone. Okay. Distribute. Have fun. Distribute. Factor. Which way did you do it, Brian?
No, I got positive.
Oh, okay. I basically did the same thing. I just found the common denominator and added first.
Oh, okay.
I just combined it.
Got it. Totally fine. Probably didn't hear Brian said he found the common denominator and added first, then did the multiplication. Whatever. Don't make a mistake with your distributing. It's going to make the rest of it really hard. Michelle, what'd you get?
I got 6. X equals 6. Right? Am I supposed to say that?
Are there 2 answers?
There, technically,
No.
one. There's only one answer
Because?
because there's the degree is 1.
Because there's what?
The degree is 1. I have no clue.
Did you get a second answer?
I got 2 other answers, but they were undefined.
They were undefined.
Also, like, okay, so what I was saying, like, instead of, like, multiplying through the common denominator, I did, like, for, like, the final, like, equation, I got negative 3 times x minus 6 over x minus 1, x plus 2 equals 0. So then you know that it can't be 1 and it can't be 2 without plugging in back into the equation. Like,
From the get-go, yes. From the get-go, how do you know that 1 is a problem? 0 in the denominator. And what's wrong with negative 2? 0 in the denominator. They're undefined. So before you're doing any of the work, I would make a note about the no can do answers. So I'm going to show you what Michelle did in a minute. Let's finish this one first.
Wait, what were the answers? There's only one answer?
I believe it's, anybody else get 6?
Yeah, that's right. It's only
Alright,
one answer.
so here we go. 3x squared 6 plus 8x plus 4. And then 2x squared minus 2 minus 4 minus 6x plus 4. Watch as I go. If I make a mistake, then we're going to have problems. 5x squared plus x plus 5x minus 10. Yes? Okay, so let's just do all kinds of multiply. Oh. Isn't that nice? 3x squared plus 2x squared is 5x squared equals 5x squared. See ya? That worked out really nice. No quadratic formula, no factoring. That was pretty. Okay, subtract 3x. Nope. That's 2x. Negative 3x. Yeah, Victoria.
I got 5x squared minus 5x.
Positive 2x. Negative 1x is positive 1x. Times 5. What is this? Negative 3x. Help me.
Negative 18.
Equals negative 18. Thank you. Oh, don't circle it until you check it. Don't circle it until you check it. I know you don't like to, but get used to checking it. Yeah? I know you did a little bit different, but totally okay. Trust me, it's going somewhere. How many answers? If I give you, this is a totally new problem. If I give you x equals 4, how many answers are there? 1. X is 4. Agreed? Okay. So if I square both sides for whatever reason, because I'm doing an example, the degree when we started was 1. The original problem, it's not even a problem. The original answer I gave you, the degree is 1. Yes?
Yes.
When you square both sides, now the degree is 2. When you square both sides, or cube both sides, or 15th both sides, whatever, you are creating extra answers, potential extra answers. Degree was 1, degree is now 2. Agreed? So you've changed the degree, which means you have changed the possible number of solutions. Follow? Okay, now, this is going to make no sense to you, but just trust me. So if I asked you to solve x squared equals 16, you would square root both sides, correct? And you would say plus or minus 4.
Yeah.
Does that match the original equation? No, the original equation says x equals 4. It doesn't say x equals negative 4. You have to be very careful when you square both sides. It's called extraneous extra. Have we talked about extraneous solutions before? I can't speak. Have we talked about that a little bit? Okay. Okay. Questions on the board from homework last night? Homework last night. Questions on the board. I believe we're on page 421. Wait, 420 slash, oh, you guys, it's the same thing. 420, 421, whatever. Some of the problems start on 420, continue to 421. Oh, why do Okay, if you don't have questions, you should be working on tonight's homework. Number 1, turn them into like terms. They're not like terms, but they can be. Root 12 is 2 root 3. 2 root 48 is 8 root 3. 5 root 147. Okay, so I don't know root 147 off my head, but I'm assuming it's probably going to be a 3 left over.
Yeah.
So 147
It's really easy.
divided by 3 is 49. So pull out a 7 times 5 is 35. Minus 4 root 3. They were not like terms when you started. They're like terms now. 10. 41 root 3 maybe? So they were not the same. The difference with like X and Y and Z, that's it. But with radicals, you can alter them and hopefully get some line terms. Okay, number 49. Which one? 27? Okay, 7 over the 4 through to 49.
Because I did it the way where you do like 7.
That's exactly what I would have done.
49 to 1/4.
1/2. This is 7 squared. So that becomes 7 to the 2/4, just 1/2. So you're going to multiply by 7 to the 1/2 over 7 to the 1/2. Add exponents to get 1. So this becomes 7 times 7 to the 1/2 over 7. Reduce. Oh, no. Oh, shoot.